Hello everyone, this is Unit 1, Day 4, Angle Measures. Okay, so we're going to be talking about the next few units, or next few sections. We're going to be using, introducing you guys to some new terms and definitions, okay, and so that when you encounter these terms later in the year, okay, you'll know what the heck we're talking about, okay? So, first thing it says, this is a ray. What is a ray? A ray is part of a line. It has one endpoint and extends indefinitely in one direction. Rays are named by stating the endpoint first, in this case which is A, and then any other point on that ray. So you can still have other points on here, right? So we'll call this one C, call this one D, okay? And so if I wanted to name this ray, I would start with my endpoint, which is A, and then I could go AB, I could go AC, I could go AD, okay? All we need is just to include another point on that line, but if you notice, we always start with the A, or your endpoint, and then whatever direction you're going, right? In this case, we run into B, run into C, run into D. Okay, so rays are named by stating the endpoint first, and then any other point on that ray. And if you notice, above AB, I have this little arrow, okay, with only one, one arrow on it, okay, and so that signifies that it's a ray, okay. If I had it written like this would let the reader know I'm talking about a line, and if I had it written like this, it would let the reader know I'm talking about a line segment, okay. And so we'll get into those further once they appear, but right now just know that when we're referring to a ray, you need to start with the endpoint, and then any other point on that ray, and then make sure you got an arrow pointing to the right, okay? So, that is a ray. Opposite rays, right, share a common endpoint, okay? So, here is our common endpoint B, and if you notice, it's going directly this direction and that direction, okay? Opposite rays are collinear, which means, if you remember linear equations, keyword line, okay, they all fall on the same line. That's what it means to be collinear. They're all on the same line. And what do we know about lines? Lines are straight and they go on forever. Okay, so just know that when we're talking about opposite rays, we're talking about a line. Okay? All right, let's keep going. An angle. So an angle is formed by two non-collinear rays that have a common endpoint. The rays are called sides of a triangle, and the common endpoint is the vertex, okay? So here is our vertex for this first one, all right? Our sides are XZ with the ray symbol, and then over here it's XY with the ray symbol, okay? So our sides are XZ and XY, and our vertex is X. So when naming angles using 3 letters, the vertex must be the second of the 3 letters. You can name an angle using a single letter only when there is exactly one angle located at the vertex. Okay, so let's think about what that means. All right, so if I wanted to name this angle right here, I can name it angle, and that's what this little symbol over here represents, right? You can either go like this, or you could go like this. I tend to write it like this because sometimes it might look like an L, okay? Just my little tricks of being a math teacher, okay? So I try to write it like this. So Z, X, Y, or we can name it Y, X, Z, or simply X because there is only one angle associated with that vertex. If you look over to the right, we cannot name it. Okay, in this example over here, we cannot name it angle X because we got 4 different angles there, okay? And so, if I wanted to name a particular angle from this bunch, okay, again, if I wanted to go angle ZXW, I could go angle WXV, angle VXY, angle YXZ. Okay, it's important to note that what comes in the middle of all of those, that X. Okay, so whenever you're referring to an angle by name, you need to make sure that you put that vertex, okay, whatever letter or number associated with that vertex goes in the middle. Okay, all right, let's keep going. Okay, angles. Angles are measured in units called degrees, okay? The degree results from dividing the distance around a circle into 36 parts, okay? So what that is saying is that we keep going around this circle, okay? We can go all the way around to 36 degrees, okay? So if your angle started here, whoops. There's my angle. All right, in which direction are we going? We're measuring up this way. All right, and so we always measure going this direction, okay? Not saying that you couldn't have an angle going another way, all right? But our degrees, okay, we go counterclockwise, all right? So talking about degrees, all right, there's special angles classified based on their degree measure, okay? And we've discussed this a little bit in class the other day when we were talking about it. You guys seem to fire them off pretty quickly, okay? I was referring to these 6 things here. So an acute angle. An acute angle is an angle who is less than 90 degrees, okay? And you can even see it up here in this chart, right? You see acute, it's right there, okay? And then the next one you'll see is right angle, okay? So here is a right angle, all right? And so right angles are exactly 90 degrees, okay? All right, what about obtuse angles? Okay, an obtuse angle, let's do an obtuse. So I see it right there. Let me get a different color. We'll go brown because brown is awesome. All right, so there is our obtuse angle. Okay, as you can see, it goes past 90, but it's still in between 90 and 180 degrees. All right, we'll go green. The next one is a straight angle. And a straight angle goes starts over here and goes all the way straight across, creating a nice straight line. Okay, so there is our straight angle. Again, there's pictures over here so you guys can see what they look like. Okay, a reflex angle is one that continues past 180 but stays between 360. So I'll do one that's not an example in there, right? So here is our reflex angle. So it goes there, and let's say it could even go like this, right? There we go. There's our reflex angle. Measures all the way around. Let me get it so you can see that better. Measures all the way around. Okay? And then finally, the last one is your complete angle, which means it went all the way around the circle and came back to 0, okay? Or is equal to 360. So anyway, these 4 are the ones we are going to see the most of, okay? All right, just an FYI. So get comfortable with what these things are, all right? And judging by the other day when we were going through them, I think you guys will be okay, all right? But those are some special angle measures that you have to remember. The acute, the right, obtuse, and straight. Okay, now let's talk about classifying angles. Okay, so it says classify each angle as right, obtuse, or acute. Okay, so I'll come back to the right angle part. Let's talk about the acute angle. So I'm going to highlight these and I'll go purple. Okay, so here is our first one. Okay, which is, let me write it up here, angle CLA. Here's another one. Okay, angle ALM. Here's another one. Angle MLB. And then finally, this last one, and my favorite sandwich, BLT, right? Who doesn't like a good BLT? So those are all our acute angles, okay? By acute, I mean they're less than 90 degrees, right? And again, we're just going by what they look like, okay? Let's talk about obtuse. Okay, because we don't know the exact angle measures here. Right? If we had a protractor, we could, but we don't. So let's do the obtuse one. The obtuse one looks like this. So it goes past 90. Okay, so an obtuse angle, let me write it over here. Okay, so an obtuse angle, angle CLB. All right, let's do another one. How about this one? Angle ALT. Okay, what about, nope, not that one. Almost did the same one. There's that. And that's about it. Right? Those are our two obtuse angles. Okay. So now, the last part you're probably wondering, what about rights? This kind of looks like a right angle, right? And this kind of looks like a right angle. Okay. And that's fine to think that it kind of looks like one. Okay. But what we have to remember is that because I didn't clarify that those two are right angles, unless I give that information to you or somehow we prove that those two angles are right angles, we can't assume anything. So when it says classify each angle as a right angle, this is all we can classify. Okay? One thing you got to remember about geometry, and especially when you get into proofs, is you can't assume anything unless it's either been given to you or proven. Okay? So in this case, we haven't proven that these are right angles, so therefore, we don't know which ones are the right angles. Okay? We can only gauge which ones are acute and obtuse. Okay? So, that being said, all right, it says rewrite each angle using a different name. Okay, I can do that. So I'm going to go angle ALC, angle MLA, angle BLM, and angle tomato, lettuce, bacon. Okay, so all I did there was just flip them around, but if you notice, what stayed in the middle? Okay, that L. Okay, so just remember your vertex always stays in the middle. And then down here, I'm going to rewrite these ones. So angle BLC and angle TLA. Okay, again, L stayed in the middle. Okay, and the last part says, what do we notice about angle ALC and angle BLT? Okay, they look very similar. Okay, so I'm going to say they look similar, but because I didn't say anything about those two angles being the same measure, okay, I cannot say that they are the same measure. So, okay, so they look similar, but we are not too sure. Right? So we can't assume anything. Just like with the right angles. They look like right angles, but we can't assume it. Okay? These two look like they might be the same measure, okay, but we can't assume that unless that information is given to us or proven. Okay? So, that being said, let's just pretend for this particular part of the lesson that I did write those two in there. Okay, so I said given angle ALC is equal to BLT. Okay, so when you have two angle measures, when you have two angles that have the same measure, what you have here is what we call congruent angles. Okay, so any angles that have the same measure are called congruent angles. Okay, and so again, in this particular problem, we can't assume those two are congruent. Okay, but if that information is given to you, that's what that means, that those two angles have the same measure. Okay, what about angle bisector? What the heck does that mean? Well, what does it mean to like bisect something, right? It means to kind of chop it in half, right? So, that being said, all right, let me put some givens here for these first few problems. So given, this is what I'm giving to you guys. So the angle CAD is a straight angle, okay, and ray AB bisects angle CAD. Okay? So, let's think about that for a second. So what does that mean? Well, what does it mean to be a straight angle? Straight angles, again, are 180 degrees. And what an angle bisector does is it divides an angle into two congruent angles. Okay? So what that means is that it takes 180, chops it in half, and now we have 90-degree angles on either side of that ray. Okay? Now, okay, this was given, so again, I cannot assume anything, all right, unless that information is given. Okay, so when we're talking about angle bisectors, okay, in this particular case, I gave you that information. I told you angle CAD is 180 degrees. Okay, and so that allowed us to find what those actual degree measures were. Okay, I'm going to do the same thing over here. So given, I'm going to say angle WXZ, so let me rewrite that, WXZ, okay, is a right angle. Okay, so I just gave that piece of information to you. I said this is a right angle. Okay, and then I said ray XY bisects angle WXZ. Okay, and so in theory, right, what do we know about right angles? Right angles are 90 degrees, right? So if this line is bisecting or chopping that angle measure in half, that means that this is 45 and this is 45. Okay, and so what it means to bisect is it takes an angle and divides it into two equal measures. Okay, that's what you have to remember about angle bisectors. Okay, last but not least, we're going to take some geometry terms and add a little algebra. Okay, so in this figure to the right, all right, we're going to use this for a couple problems. KJ, the ray KJ and ray KM are opposite rays. So that means that we got a nice straight line right there. Okay, nice straight line. Okay, opposite rays. And KN, the ray KN, bisects angle JKL. Okay, so what that is saying is that it is creating two angles of equal measure. Okay, and if you're looking at those little symbols I'm putting in the angles, that lets the reader know that those two angles are congruent. Okay, sometimes they might have one, right? Sometimes they might have three, depending on how many angles you have in the problem. Okay, just so you're aware, though, that's what those symbols mean next to those angles. Okay, so if KN bisects that, we know that these two pieces, these two angle measures, are congruent. Okay, and so if the measure of JKN is equal to this expression, so that's 8x minus 13, and the measure of NKL is equal to 6x plus 11, all right, how can I solve to find the measure of the measure of angle JKN? All right, so let's think about this. So let's follow along what they did here in the example. So they said solve for x. That's the first thing we need to do. Okay, so since KN bisects that angle JKL, I know that, like I said, those two angle measures are congruent. So by definition of congruent angles, we just said the measure of angle JKN is equal to the measure of NKL, okay, by the definition of congruent angles. Okay, that's what congruent angles state. They have the same measure. Now, using substitution, I'm going to take the value that they gave me for the measure of JKN and substitute it in for this piece right here, which is 8x minus 13. And then I do the same thing for the measure of NKL. I substitute that expression in. And now I'm just solving a multi-step problem. Okay, so you can follow along with the rest of the steps. You get the x's on one side, the constants on the other. Isolate the x's. In this case, you're taking 24 divided by 2, and you get x is equal to 12. Okay, I don't think I have to really go through that. We've done multi-step problems in the past. All right, so now that I've gotten this value of x equals 12, my next move is I'm going to use that value of x to find the measure of jkn. And so I take the expression they gave me, which is this guy right here, and I take that value of 12 and I substitute it into x. And by doing so, you get 83. And so the measure of jkn is equal to 83. Okay? Let's clear it out and let's try that one on the bottom. Okay? Now we're going to have to work through this one on our own. All right? So it says suppose jkl. Now we're using the same thing. We're supposing all this stuff over here in this figure. We're just changing the numbers a bit. Okay, so it says measure jkl is equal to, so let me highlight that, jkl. Okay, that's 9y plus 15. And then the measure of jkn is 5y plus 2. Okay, so everything's still applied from the beginning there. Kn is bisecting this jkl, right? And so what we're going to have to do, all right, is set up a problem like we did up here, and so that we can solve for that value of y and substitute it back into the expression. So let's think about this. Now in this case, they're giving us the value of that jkl, all right, of that measure we're trying to find. And so we have to actually take a step back and think, okay, what does it mean to bisect something, right? So when you bisect something, you create two angles of equal measure. So if you think about it, if jkn is equal to 5y plus 2, well then this better be equal to 5y plus 2 as well, right? Okay, we don't know what y is, but I certainly know that this expression, okay, this numerical value is going to be the same for either side of those angles, okay? And so in order to find that, let's set up a problem here. So the measure jkl is equal to, now if you think about this, right, we're bisecting jkl, and the values, the expressions they have is 5y plus 2, right? So if I wanted to find out what my total value is, all I would have to do is I would have to add up this angle measure and this angle measure, and that will give me the full angle measure, okay? I'm pretty sure that's the angle addition postulate, right? What that means is, so if you have an angle, let's say this angle, it's a little slightly to the right. Let's say the angle is 88 degrees, okay? And so you bisect this angle. That means we're no longer 88 for each of these angles. We're at 44 and 44, okay? But if I were to add 44 plus 44 up, I would certainly get the full value of that entire angle. Okay, so the same thing applies here. Okay, to get the measure of jkl, I would have to add the measure of jkn plus the measure of nkl. Okay? And now I can just do some substitutions in here. All right, so I'm going to substitute the measure of jkl for 9y plus 15. And the measure of jkn is equal to 5y plus 2. And again, because they're both of equal measure, they're both congruent, I'm just going to write 5y plus 2 again. I'm going to simplify the right side. I'm going to subtract 4. I get 9y is equal to, 9y plus 11 is equal to 10y. Subtract 9y. 11 is equal to 1y which is just y is equal to 11. Okay? Anytime you divide anything by 1, you just get that same number. So our value for our y is 11, and then I just plug it into this expression. So I go 9 times 11 plus 15. So I get 99 plus 15, which is 114. So my answer is 114. And I think that's it. Okay, so the rest is for homework. Okay, bring any questions to class. Hopefully this is helpful, and I will see you guys next week. Adios.